my computer. There we go. Well, welcome, and especially welcome, Nava. Thank you for taking up our request for you to share with the Climate Mental Health Aotearoa network an opportunity to hear from you about your understanding of the climate science. So over to you.
Thank you. I'll just get you to share my presentation since I will be letting you know when to advance. But kia ora koutou, ko Nava tōku ingoa. I am going to start with just giving you a bit of background about myself. I work at what is now known as Earth Sciences New Zealand, formerly NIWA. And from July 1, NIWA and GNS kind of merged, and that is the name of the new organization. And we can go to the next slide. In terms of my background, I started at NIWA in 2014 as a climate scientist, and mostly did work not so much on the modeling and the projections themselves, but communicating them, producing maps and reports and guidance to councils or businesses or government agencies and things like that. And we've at the time the kind of what we call the CMIP 5 projections had been produced, and so there was new modelling when I started that was kind of ready to be shared. And July last year, when the updated modelling came out, and so we're kind of doing a very similar process now. So a lot of the science and information that I'll share today is based on these updated projections, which have recently been completed. I also kind of partway through my career spent time at the UK Meteorological Office and retrained as a weather forecaster, and then worked more on weather forecasting services. And my current title is I'm the manager of climate, atmosphere and hazards at NIWA, which is one of our science pillars where a lot of science gets kind of done underneath that broad umbrella. I've traveled through my work to some of the Pacific Islands. Some of these are very heavily impacted by climate change, like Tuvalu, where the height of the land is only 1.3 meters above the sea and the maximum. So you can imagine that sea level rise is a big concern there. Kiribati would be another place where I spent some time, where some of those challenges are really hard hitting there already. And I did Enviro schools, actually. There was a mention of some of the attendees when I was in high school. It was, I think, in the infancy, but that was where some of my passion for environmental science kind of began. We spent a week at Lincoln University, I remember, and I learned a lot about different environmental science. So that was one of the catalysts for me to study geography and environmental science at Auckland University. And that's where kind of I did my study. I also have proposals and project management. I think, the life of a scientist sometimes sounds very glamorous, traveling to these islands and things like that. But there's a lot of computer-based work as well in doing that kind of stuff. So we can go to the next slide. Today, I just wanted to mostly share the projections that I mentioned that have recently been updated and what the kind of impacts from those that might be. But I always like to kind of start by looking backwards before we start looking forwards. So in Aotearoa, New Zealand, we have various climate records that tell us about how environment has changed over time. One of these is we measure carbon dioxide in the atmosphere. There is a really important record in Hawaii, in Mauna Loa, and that is the grey line on this graph here. So it shows the record of carbon dioxide in the atmosphere. And the red line is a record that we have here in Bering Head, so at the entrance of Wellington Harbour. And it is it's there from 1977. It is the longest record of carbon dioxide in the southern hemisphere. So it's a very important record globally. We're very kind of fortunate to have this long record. Both of them show the same thing. The trend is going up. The reason Hawaii kind of wobbles a bit more is because in the northern hemisphere, there's more landmass, there's more deciduous trees, and that's essentially the earth breathing. It's the seasonal cycle, and we don't have that as much in the southern hemisphere. But they're kind of showing the same thing, that carbon dioxide in our atmosphere has been increasing. And if we go to the next slide, we see the impact of that in our temperature record. in New Zealand, we have something called the 7-station temperature series. If we kind of add up these long lived temperature records, weather stations around the country back to 1909, we can see that temperature in New Zealand has decreased by about 1.1 degrees kind of over a century. But a lot of that warming has actually happened in the last decade. So what we're seeing here is often called climate stripes. If we take the average, so the average temperature between 1991 and 2020, and then we say, well, how does the temperature compare to that? If it's blue, it means it was colder than that, and if it's red, it's warmer than that average. So we can see relative to this quite recent average period, the past was cooler, and more recently it's been warmer. And in that record that extends over 100 years now, 10 of our warmest years have, 8 of our 10 warmest years have occurred since 2013. And if we go to the next slide, we see a change in 1 degree in temperature. For many, it's very difficult for us to feel a change in climate. The temperature changes more than 1 degree day to day. But what it's really doing is kind of what's illustrated here, is we're taking your kind of climate system and just shifting it, which means that extreme hot temperatures become much more likely, and we can set lots of new records at that tail end. Doesn't mean that you don't get cold weather, that, you know, it is cold right now, especially I'm in Wellington, I'm usually in Auckland, so it's much colder for me here. So cold snaps still happen, cold seasons, even kind of years, but they're just less likely to occur compared to warm weather. So we're kind of shifting our whole climate distribution. And in the last decade, there are on average 4 to 5 times more extreme high temperatures than we would expect in a climate that had no long-term warming. So we're seeing that. Another area where we're seeing our climate changes in our glaciers. In New Zealand, we have this, we're really fortunate to have this record of a glacier volume since 1977, thanks to a man named Trevor Chin, who piloted this, what's called an end of summer survey flight. So at the end of summer, when all of the melting has kind of finished, he would fly around a lot of the glaciers, take photographs, and so we have this photographic record since 1977, and now we continue to do this annual survey to see the change. Through that science, we know that we've lost about 1/3 of our volume of our glaciers during that time, which has quite important implications for it's our water storage. A lot of it's used for irrigation and things like that. So in particular in the South Island, there's a lot of implications to that. Glaciers are also a really good way for us to understand how climate is changing, because glaciers don't respond to a hot day, even a hot week or a cold day. It's really that accumulation of these events. And so the retreat is showing us that it is the kind of the shift in the climate. It's not it was hot or cold today. So they're a really important record for us. If we go to the next slide, we also have sea level records around the country since around 1900s, and on average we've seen about 20 centimeters of sea level rise through that time. It is something that's also very gradual in many places, a millimeter kind of every year, but then it adds up when you kind of look over a century. Sea level rise is complicated because you also have vertical land movement. I know that in, like, the Kaikoura earthquake, for example, there was parts of Canterbury that jumped up 6 meters, and in other parts of the country there's a lot of land sinking. So that has to be taken into account around what the relative sea level rise is. And the next slide, marine heat waves are more common and our oceans are more acidic. So we've seen that in recent summers, really warm temperatures, fantastic for beachgoers. But there are some negatives to that. In Marlborough, as mentioned, there's the king salmon farms. So many of them had to close because of the high volume of fish deaths. So the conditions were not suitable for that type of thing there. And finally, I think we kind of know that extreme weather is more intense and frequent. We've been living through that basically every year. There's big events now. And we know that for the twin climate disasters from Auckland Anniversary and Cyclone Gabrielle, just as an example, there was over 100,000 insurance claims and more than $3.5 billion worth of claims. So it has a big impact on all facets of society. So that's looking back. But if we want to understand what might happen in the future, we essentially need to do modeling. So the way that climate modeling is done now is we need these things. These are supercomputers. It's only really possible to do these types of projections using supercomputers because you're essentially having a model of how the Earth works, all of the maths and physics that we know. How does gravity work? How does clouds work? All of these are equations, and they have to go in there, and it's just thousands of calculations. And from that, we can start to get projections of what the climate might look like. So on the next slide, there's a bit of an explainer around how when this is done globally, we use global climate models. So these cover the entire Earth, and to be able to cover the Earth, this grid squares that we're predicting the future climate for is quite coarse, so about 100 by 100 kilometers. So we're not getting a lot of detail when we're dividing the Earth up that way. So at NIWA, Earth Sciences New Zealand, we take that global climate model data, and then we do something called downscaling, and we get it to a 12-kilometer resolution. And then we use local observations to bias correct that data to make it more relevant for us and our kind of topography and region at a 5-kilometer resolution. So the projections that we have for Aotearoa, New Zealand have recently been downscaled to this much more granular 5-kilometer resolution. Why is this important? So in the next slide, there's an example of that. It's important, especially in a country like New Zealand, because we have from the Southern Alps some varied terrain. So this image here is showing what the elevation looks like in a model that has an 100-kilometer square resolution on the left versus a 5-kilometer resolution on the right. So we can just see that a model that has an 100K resolution, it's really flattening out our peaks and things like that. And we get a lot more detail out of a 5-kilometer resolution model. That means that we're better capturing important processes that influence our climate, that why it's wetter in the west and dry on the eastern side of the Alps and things like that. We need to be able to capture these types of processes. So there's a lot of value for us to do this downscaling work, which, by the way, on the NIWA supercomputer took 1 year to complete and used 70% of the computer. So it takes a lot of time and resource and cost basically to run these giant computers and to crunch all the numbers to get these projections. The biggest uncertainty in climate models is obviously uncertainty with some of the processes in physics, but the biggest uncertainty in terms of what the future of the climate might be is actually more around socioeconomics and what humans do. So obviously we're the ones that are contributing to greenhouse gases in our atmosphere, and to be able to understand what the future climate might be, we need to think about what the greenhouse gas concentration in the future might be. And that depends on things like, when is population going to peak? Are environmentally or kind of green technologies going to kind of kick in, and we're, people going to be driving EVs? Is there going to be wars and people kind of pooling resources, or are they going to be holding them like kind of nationally? So to try to make some sense in this, we use what we call shared socioeconomic pathways, or SSPs, in the models. You might see some of that type of language. And the pathways are kind of assume these different types of futures and say, well, if the world was like this, then these would be the emissions, and therefore this would be the kind of climate that would see. Or in this case, we're looking at the temperature projections. And the main thing that you can take from this is that if we're looking at future climate at, say, the 2050 year mark, there's not that much difference between the pathways in the near future. And so the choice of which kind of projection you look at is not as important. But if you're making decisions out to 2100, maybe you're building a big bridge that might still be there, land use planning, you kind of need to consider potentially different scenarios. And none of these are necessarily more likely than the other, because they're all meant to be plausible futures. So it shows that our actions do matter, and they kind of set which path we take. And there are many options. And so society really is the driver behind that. So what do these projections show us for Aotearoa New Zealand? So in terms of temperature, if we look at the next slide, by the end of the century, average temperatures could rise by around 3 degrees if we look at the rockier scenario, but less than 1 degree if we follow a sustainable path. So in other words, that warming is inevitable, irrespective of scenario. However, our actions have a direct effect on the magnitude of the warming that we expect. And on the next slide, we kind of see the same thing that I talked about before, is that these numbers are small, but it shifts the system. And so even, a 1 to 3 degree jump actually has a big impact on temperature extremes. We see that a little bit in the next slide where, for example, in Auckland, we currently average 30 to 40 hot days a year. So a hot day is defined as a day where temperatures are 25 degrees or higher. So about a month of those in Auckland a year. But by the end of this century, there could be an additional 70 to 80 hot days per year under the Rocky pathway, but more like 20 to 30 a year if we work to stay on the more sustainable path. So you get big differences in those extremes depending on which one of these pathways that you look at. And Wellingtonians average 5 hot days a year, might be very welcome to have some hotter temperatures. And there are definitely impacts that are positive. So not all impacts of climate change are negative. There's lots of opportunities, which I'll talk about. Certainly being able to kind of enjoy being outdoors and going to the beach, that's one nice impact. But some of the downsides are, so the horticultural cycles, I should say, are being affected. We already see a little bit of that. Some of our crop, the kiwi fruit, require winter chilling. You get less frosts, and so some of our crops rely on that. And on the flip side, there's actually opportunities there of new varieties or different things to grow. I was involved in the project in the Kaipara where they were looking at crops that could be used to grow alongside the staple kumara to kind of supplement that might be good in the future. So we're looking at varieties. The Pix peanut butter did a trial of peanut growing on the Poto Peninsula there. And that would have been a climate previously unfavorable to something like that, but all of a sudden there are new opportunities. So these projections are really useful to be able to identify that type of thing. Obviously of relevance here is the impact on physical and mental health. From the physical health perspective, it's just around working outside, and especially for older and vulnerable populations. We see this playing out much more in overseas where there are these major heat waves. In some countries like the US, they are building cooling centers where people can go during hot weather. So they kind of spray water and things. And so because you might not have air conditioning in your home or unable to kind of escape the heat. So it's something that we are a little bit sheltered from over here in New Zealand, but that doesn't mean that wouldn't be a bigger issue in the future. Changing energy demands is another big one. Some positives there in terms of less requirements for heating in winter, but then the flip side to that is more requirements for cooling in summer, and that doesn't really coincide with our kind of the rainfall patterns where we use a lot of hydro generation, and our wettest time of year is obviously winter, and that's when we kind of need energy less maybe now, but when we need it more, it's actually potentially going to be drier. So that's kind of an issue as well. New exotic pests, animals, weeds, and diseases. That's across our terrestrial and marine and our freshwater environments. We're seeing kind of a lot of that. A lot of things. New Zealand's very lucky because we just have this giant moat around us and no neighbors, but all of a sudden, all of these tropical things that used to say, oh, it's too cold here, or they might come here, but then in winter it's cold and then they die, so they don't establish. all of a sudden that's not necessarily happening. And so that's a really big thing that we do a lot of research around that, and also working with NPI around biosecurity and trying to see if something does come here, is it likely to establish or maybe not. So that's kind of an important piece. All of this kind of stuff can lead to economic stress from kind of because of agricultural productivity or water shortages or impacts on tourism and things like that. And we know that there's unequal exposure and adaptation. So lower income and rural communities often have fewer resources to prepare and mitigate some of these impacts. Yep, I think that's all I'll say about that. Jumping to rainfall projections. Rainfall is a little bit trickier in the sense that when we look at so we've got different climate models, and we have those different scenarios, and we can look at different timescales. When we look at temperature, all of the models show warming. It's just the magnitude of the warming is different. When we look at rainfall projections, there is in some locations, there is disagreements. They might say, one model might say, oh, it's going to be wetter here, and another might say it's actually going to be drier. But then there are parts of the country where there's a lot of agreement, and the west coast of the South Island is one of those that's expected to get wetter there. And then some of our drier places already are expected to get drier. So almost an exacerbation of what we already have. Importantly, there's a big seasonal impact as well. So we can look at rainfall changes over a whole year, and you might think, oh, well, it doesn't look like it's going to really change much. The total rainfall stays the same. But when we break it down by season like this, we actually see that you're changing the seasonality of your rainfall cycle, and that maybe you are going to be kind of drier when you don't need the rain, and wetter when you do need it. So that's an important consideration when looking at rainfall projections in particular. You can break it down even more by month, because there's some industries that particular month or something is very important for them. And so you want to see, well, what's kind of happening there. So extreme rain and storm risk. So the reason that we are seeing more extreme events, or why here, or climate change is causing more extreme, especially flooding events, is very simply put, a warmer atmosphere. Just by warming the atmosphere, you can hold more water. Imagine it like a sponge. You wring it out and water comes out of it. By warming the atmosphere, we're making the sponge bigger. So that same rain event that you might have had 50 years ago, the sponge was smaller, so you don't get as much water out of it when you wring it out. And that's kind of what we're seeing the impact of here. So that when we do get wet weather events, they're more likely to be you see more rain in them, and then you get increase in frequency, because previously a rain event might have been like a nuisance event, maybe some surface flooding, and now that tips into something that might have some more serious impacts. I think we're very kind of well versed in the types of impacts that these types of events have, but just kind of, and I'm sure that this is, you deal with a lot of this, but things like the acute stress and anxiety, maybe PTSD around if you were involved in a kind of experience, say the recent flooding events or Cyclone Gabrielle. I was actually 2 weeks ago, I represented NIWA at the coronial inquiry into the deaths of Cyclone Gabrielle and Auckland anniversary. So I've been dealing a lot with reading about those events and kind of the impacts of that. So very kind of front of mind for me at the moment. Grief and trauma from just loss of homes, pets, livelihoods, community structures. A lot of even those events that were now 2 years ago are in some places, very early stages of rebuilding. And yeah, displacement and housing stress. So it's really tough, anyone that's kind of going through these. The other kind of thing I'll note around that in the social sciences, we've done some research around people that are actually, like the controllers that are involved and the CDM staff involved in issuing the warnings and trying to coordinate flood response or emergency managers, and how there's a lot of burnout, kind of limited staff. There's a lot of, we did this for the West Coast where there were 3 back-to-back flood events. And so you have these like repetitive events where you haven't really taken stock of the last one before you go on to another one again. So that's kind of another area with flooding in particular, where we're seeing a lot of strain on people, really. And then the next slide, on the other kind of side of the spectrum, we are also expecting more dry days in New Zealand. So it's almost like when it rains, you get the binge rainfall. So a lot of rain comes at once, and then you just get extended dry periods. And we're seeing some of this happen actually, Melbourne, top of the South Island there. You almost go from a drought situation early in the year where there's just been no rainfall, and then all of a sudden you're getting all of this rainfall, and it actually exacerbates the impacts because the ground is dry. You don't get very good absorption, you get more runoff, and so you get greater flood impacts. So you kind of get, it's a bit of I kind of see that the future climate is almost like an extreme version of what we currently have. So even more dry, even more wet, even more kind of hot temperatures than we currently do. The dryness combined with warmer temperatures and slight increase in wind speeds also increases fire risk and fire weather. We work really closely with FENS, and the positive, or the way that they can mitigate that, and they do, is that knowing this type of information means that there's a lot of science and information around forecasting that they can leverage to mitigate some of that risk. So we provide, for example, seasonal outlooks to FENS as we start to go into the fire season. So we're talking more around the other, like climate drivers, natural climate drivers. Oh, it's going to be a La Nina, and we might actually have a dry summer. Or actually what they're worried about is if it's wet coming up to summer, so you get a lot of grass growth, and then it goes dry and all that grass dries out, so there's a lot more fuel. So all of that type of information is used to understand, do we need to be doing kind of proactive management? Do we need to be putting the fire seas, starting it early? And then we do forecasting services as well, and that's more around staffing. Okay, we're expecting fire weather conditions in these areas, so we're going to have more people in our call center, and we're going to station people here. So there's a lot of great work that's been happening in a lot of organizations who understand the longer term impacts and the changing kind of trends in the climate, and are putting a lot of effort into kind of adaptation and mitigation, so that even though some of these events are kind of out of our control, our ability to respond to them is better. So that's kind of exciting to be part of. And then I'll just finally finish with just some coastal and marine projections and impacts. I talked about before, if you go to the next slide, that a lot of there's a great website if you want to go to it called searise.nz, and there you can look at the sea level rise projections are along our coast. That's kind of the map on the right hand side, but it also shows you that vertical land movement I talked about, and the blue dots are showing where land in New Zealand's actually sinking. So in many places around the country you have both happening at the same time. There is a lag in the ocean system compared with the atmosphere, just because of the thermal inertia of the water. So even if we just stopped warming today, like no more emissions, nothing, we are still expecting about a 20 centimeter rise in sea level by 2050, because that's already the warmth that we've already added. So this kind of lag behind. And that's kind of really important around, especially for people involved in coastal planning, is that we're paying catch up in some of that. Some of our work, one of the big impacts around sea level rise is we're doing some work, for example, at the top of the South Island with Rangitane around and the Marlborough Sounds, and loss of cultural identity or place around like Urapa that may be affected by sea level rise and things like that. So there's a lot of some of our research is going into that and weaving Mātauranga Māori and how to preserve some of our key cultural sites and places of significance where basically sea level is rising. I talked a little bit about this before, but with the sea level rise is that there's a bunch of different impacts that come out of that. One is what you get more coastal kind of flooding or inundation events, and you can increase your salinization of your groundwater, which if you have kind of coastal crops and soils, that will impact there. You also get a squeeze of some habitats. If you imagine you had mangroves or some sort of habitat here before, in a natural environment, if there was no kind of urbanization, then sea level would rise and that whole thing would just kind of go backwards. But because you've probably got some built up areas behind it, you get the coastal habitat squeeze. So that's another kind of one of those impacts. Yeah, and in some places it's kind of nuisance flooding events becoming more common. I know in Auckland, Tamaki Drive, that's like a common one where you get maybe a couple times a year a flooding, like a big storm, and you will get and it coincides with a high tide, and the road is closed and you can't drive there. They're now actually trying to mitigate that impact by raising the road and improving the seawall. But if nothing was done, you would expect that type of impact to become more common, and then all of a sudden it's not just like a once a year thing, it actually becomes a kind of every other week thing. And some people will experience the impacts of sea level rise in that way. Not necessarily that this, the water is just going to be really high all of a sudden. And if you're not experiencing some of those impacts now, it's those kind of nuisance type events which will be probably most noticeable. And marine heat wave impacts. So on the next slide is kind of my last slide. I talked about that a bit in kind of what we've already observed, and we are expecting those to become more common and seeing kind of more of those marine pests and diseases. But there's, like with the crops, there are kind of opportunities there as well. Some of our marine species do really well in warmer waters. We've seen some kind of booms in some of our snapper fish stocks and things like that. Other species, not so much. Little blue penguins have suffered recently, not because they are impacted by the temperature so much, but their food sources. And so there's been kind of starvation of those. So there are winners and losers in this kind of change, and a lot of our science focuses on understanding specifically what those might be, and especially when we come to fish stocks and things like that, if we are relying on them as a food source and setting fishing quotas, it's very important to understand what those future impacts might be so that we kind of make appropriate decisions. And yeah, just wanted to just finish with a couple of resources. One is that the data that I was talking about, MFE were the ones that paid for all of that science, and it is online at that link there. There's a map viewer. You can look at the different variables and the projections, different scenarios, different seasons, different years in the future. So that's kind of useful if you're wanting to get a sense of in your area how the climate might change in the future or for decision making. And then the other resource is we have on our website a few different resources, but this one, there's just a pool of pages around climate change information for climate solvers. It is generally aimed at, I think, more like high school kids, but actually the content is useful for adults as well. I wouldn't say it's kind of kid specific, so it's a useful accumulation of resources. I'm very that's all I have, but I'm very mindful that when I talk about climate change impacts, one of the difficulties I have as a communicator is that I just feel like I deliver a lot of bad news and negative things. And it is true, that is like these are the potential impacts of climate change, but I kind of see the value of doing the projections and the science is having that type of information so we can make good decisions. And this kind of the update and the resource, it's so valuable about using those projections and thinking about, okay, where are we going to build things? Where are we going to plant things? How is my business going to be impacted? We can make decisions that are kind of more robust by incorporating some of that information. And so I hope that like understanding the impacts is not a kind of a doom and gloom, but as a, like, I'm kind of armed with the kinds of impacts that could occur, and that let's now think about how what I can do in my own kind of life, business, whatever community, to mitigate some of those, because what the projections mean and the impacts will be different for an individual, a community, different, somebody in different circumstances. Something that, like I said, like, you know, hot days are great for going to the beach, but bad for something else. So it's not so clear that what the impact of some of those environmental changes might be. And it's about kind of everyone to put their own hat on and think about, oh, well, for me, this means X, Y, Z. So yeah, hopefully that was useful, but we can probably stop recording. I'm happy to take questions and discuss anything.
No, thank you so much. That was so great to have that clarity around these complex interrelationships between the physical change, between the future and the present and the past, between the physical observable realities that you can measure. And then it was fascinating to hear how the computer works to kind of then convert that information and bring so many variables together. And then, of course, what you were saying about the social aspects, the things that we don't know about how people are going to respond. And that's very much the reason why we have this emerging climate mental health network in Aotearoa. So really thank you for your contribution, and I'm sure it'll be a great resource for us. Can I just ask you, I'm sure others have got questions, but can I ask you to say a little bit more about how it is for you? Obviously, this has been your career and you've had lots of really interesting areas. Are there moments for you when you feel genuinely anxious or worried or
Yeah,
pissed
that's a
off
good
or
question.
frustrated?
It's difficult when it's your day to day. There's a danger of it just being kind of just normalized, because it is the type of the type of information that I see all the time, and so, you know, the impacts are not shocking to me. I'm like, yeah, this is what's going to happen. But then, yeah, I think for me, the things that it does, this type of information does influence my personal decision making, and kind of things that, you know, the things that I choose in my life and how I want to live, and try to be kind of more green and think about the influence I can have at various level on like my personal day-to-day life versus what I can have influence at work. The things to me that are more shocking are things like what's happening in the US right now, and some of the loss of some of our climate scientists in the community and observing networks. That was probably one of the most recent things that was shocking, that there has been a lot of global effort in this space and the expansion of science. When I started as a climate scientist, you know, at NIWA more than 10 years ago, there was plenty of science being done there, don't get me wrong, but in New Zealand it was quite limited to the institutes and maybe a couple of council staff, and now it is the type of people coming for advice like yourselves. It's so much more broad. Nobody really cared about the projections 10 years ago. It was just councils had to do it. And so to see that kind of rolling back in really important global communities, I think that was like very surprising and a bit shocking to me.
Do you find that you need to do things deliberately to attend to your own well-being?
Yeah, sometimes, yeah, I think so. It's around kind of engaging and how much you engage with it. I think it's very easy to fall down that rabbit hole and start thinking around, well, you know, what can I actually do? And, you know, these other bigger countries and bigger policies, they have this effort, and like, I think you can kind of either adopt that mentality or think, well, I try to sit with the mentality that is like, you're either part of the solution or you're part of the problem, and that's your choice. And that's kind of my way out in terms of if I ever start going down that type of track. Yeah.
Well, thank you so much. I will stop the recording now. So thank you.